In this video, we are going to have a short discussion on atomic structure and Dalton's atomic theory. Kindly like and subscribe to the channel after watching so that you keep in touch with every update from this channel. Matter is basically made of a reactive portion we call atom. So every matter is made of atoms which take part in a chemical reaction. And in fact, they are the smallest particle of every matter. So every matter is made of atoms, and the atoms are very small and they have about a radius of 0.1 nanometers. Atoms can even further be divided into other subatomic particles, which are called protons, neutrons, and electrons. So when you take this structure, this is an atomic structure which shows how the subatomic particles are distributed in space. The central portion of the atom is called the nucleus. Here we have the neutrons and the protons, which defines the mass of the atom. Outside the nucleus are what we call the shells. These are the shells or the orbit in which the subatomic particle electron revolved or surround in. So the electrons are found outside the nucleus in the shell of the atom. So we have basically three main subatomic particles in their protons, neutrons, and electrons. Protons carry a net positive charge in the nucleus, whereas the electrons carry a net negative charge around the shell. The neutrons also have a charge of 0, and protons have a mass of 1, neutrons have 1, and electrons have a mass of 0, which means that when we take an atom, what defines the mass of an atom is the number of protons and the neutrons in an atom, because the electron mass is negligible or 0. Several discoveries were made by earlier scientists as to whether an atom or a matter is composed of atoms. We have the theories of Dalton, who did chemical combinations to see if indeed matter is composed of an atom. We have a scientist called Thompson, who did an experiment called CRT experiment to discover if atom is indeed made of electrons. We have Rutherford, who did an experiment also to discover if indeed matter carries a positive charge. In this video, we are going to look at a scientist called Dalton and his contribution to the atomic theory. Dalton did an experiment by chemical combinations. He combined several atoms from different elements, and per his outcome or the result, he came out a theory to say that in fact matter is made of atoms which take part in a reaction. He divided his theory into 4, and the theories were named the Dalton's atomic theory. So after his chemical combination experiment, Dalton discovered that matter is composed of tiny indivisible particles called atoms. So he discovered that every matter is made of tiny and indivisible particles called atoms. So per his theory, he was trying to say that the atom in a matter is very tiny and can never further be divided. He also discovered that atoms of the same element are identical in mass, and for that matter, that of different elements are unidentical or different. So this was the second observation that he observed or he came out with after his chemical combination experiment. He also discovered that in a chemical reaction, atoms can neither be created nor destroyed. That was his first or the third theory. He said in a chemical reaction, atoms can neither be created nor destroyed. Maybe he combined two different atoms and realized that at the end, he had the same atoms as the product. So he said in a chemical reaction, atoms can neither be created nor destroyed. Lastly, Dalton postulated that in each of their compounds, different elements combine in some simple numerical ratio. So for example, one atom of A combines to one atom of B to form compound AB. So this one, it means that in every compound formation, the atoms in the element combine in a numerical ratio. So we have 1:1 ratio in a compound AB if you have one atom of A combining to one atom of B. So for example, when you take a molecule of water, Water has two hydrogens and one oxygen. So the ratio of the hydrogen is to the oxygen is 2:1. So they have a simple numerical ratio. Later scientists also came and did several experiments concerning Dalton's theory, and they found out that some of these theories were wrong. So some of these theories were disapproved or later accepted as false. So let's look at some of the theories which were accepted as false. Further discoveries realized that the postulate 1 of Dalton, which states that matter is composed of tiny, indivisible particles called atoms, was not true because atoms can further be divided into protons, electrons, and neutrons. So we take this structure of an atom, we can further divide the atomic structure into protons, into neutrons, and even electrons, and even shells in an atom. So the first postulate that matter is composed of tiny indivisible particles called atom was disapproved or was wrong because matter can further be divided into protons, electrons, and neutrons. Again, his second theory that some atoms of the same element are identical in mass and that of different elements are different was disapproved because some elements exist as isotopes. So some atoms exist as isotopes. So we have different in masses. So isotopes are basically two atoms of the same element that have different number of neutrons. So if they have different number of neutrons, they will tend to have different masses, that is different mass numbers. Bear in mind, we said earlier on that the neutrons and the protons in the nucleus defines the mass of an atom because they have mass of 1,1. Electron is not counted because it has a negligible mass. So if an atom has different number of neutrons, then it means to have different number of masses. So isotopes are basically atoms of the same element with the same atomic number of course, but different mass numbers due to different number of neutrons in the nucleus. So if you have an atom like an oxygen atom that can have different number of electrons, it means to have different mass numbers. So his theory that atoms of the same element are identical in mass was disapproved because of the theory of isotopy, or because of the existence of isotopes. That theory was disapproved by later scientists. Also, his last theory that in a chemical reaction, atoms can neither be created nor destroyed was also later disapproved by some scientists who did a nuclear reaction and realized that some elements or some atoms react with some radioactive radiations and they get destroyed. They either increase in mass or reduce in mass. So when you have an atom like the radium with a mass of 226 and atomic number of 88, when it reacts with a helium or a beta radiation in a nuclear reaction, this atom can change to this. So in this reaction, this atom is destroyed to this when react with this radioactive isotope, and this atom is created. So in a nuclear reaction where there is a spontaneous disintegration of the nucleus of an atom, atoms can be created nor destroyed. An example, we have a beta radiation reacting with uranium atom with a mass number of 239 and an atomic number of 92. When this atom is very reactive and subjected to beta radiation, it will lead to production of different atoms with different mass, same mass number, but different atomic numbers, meaning different atom altogether. So in this reaction too, this atom is destroyed to this and this atom is created. So Dalton's last theory, or the third theory, that in chemical reaction atoms can neither be created nor destroyed, was disapproved because atoms are created and destroyed in a nuclear reaction. So these are Dalton's atomic theory. Thanks for watching. Don't forget to subscribe, like, and share to whom it may concern. Thank you.